In this video, I will show you how to identify and fix errors in MATLAB code. We will walk through a simple live script that calculates the sum of every second element in the Fibonacci series until target sum is reached. However, there are some errors in the code. Our task is to find and correct these errors. The Fibonacci series is obtained by adding two previous elements, with the first element in the series being 0 and the second element in the series being 1. As seen here, xn plus 1 equals to xn plus xn minus 1. Following this formula, the first 12 Fibonacci numbers are 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and 89, calculated by adding the first two elements. So 1 equals to 0 plus 1, 2 equals to 1 plus 1, until we get 89, which equals to 34 plus 55. The sum of every second element in the first 12 numbers is 1 plus 2 plus 5 plus 13 plus 34 plus 89, which gives 144. The objective here is to find out how many elements need to be added to get a sum of 144. Below is some buggy code. This code doesn't contain any syntax errors, so when we run, MATLAB won't flag any errors, but the bugs in the code will prevent it from outputting the correct answer. We'll now go through the code line by line to explain how it works, and after that, we'll try to debug the script. At the beginning, we clean up the workspace using clear and CLC. Then we set a target sum of 144. Then we initialize the first two elements of the Fibonacci series, which are x0 and x1. So we initialize them to 0 and 1 respectively. Sum and index are initialized to 0. Then we initialize variables to hold the previous two Fibonacci elements. Xn stores current Fibonacci number, which is initialized to x1, and xn minus 1 stores the previous Fibonacci number and initialized to x0. We then have a while loop, which checks if the sum is less than or equal to the target sum, so it stops after the sum is larger than the target sum. Inside the loop, this line calculates the next Fibonacci number by summing the two previous numbers, xn and xn minus 1. And these two lines update the variables to move forward the Fibonacci sequence. Xn minus 1 takes the value of xn, and xn is updated to the newly calculated Fibonacci number xn plus 1. Then we increase the index variable to keep track of the current position in the Fibonacci series. And if the remainder of the index divided by 2 is 0, which means the index is even, the current Fibonacci number is added to the cumulative sum. So if the index is 2, 4, 6, so forth, the current Fibonacci number will be added. The final line displays the total sum of every second Fibonacci number after the loop completes. It also shows how many Fibonacci numbers are added. Let's first run the code to see what the result we get. We can see that in the workspace, we get an index of 12 and a total sum of 376, which is greater than our target sum 144. So it suggests that something is wrong with the code. So what we can do is to step through the code line by line. To do this, we first put an anchor on the first line. Then we use the step button to step the code. So target sum is 144. The first two Fibonacci numbers are 0 and 1. The sum is 0 and index is 0. Xn is 1 and xn minus 1 is 0. It looks good. Then we enter the loop. Xn plus 1 gives 1, which is a summation of 0 and 1. And it's correct. And then xn minus 1 and the xn are updated to 1 and 1. And the current position is moved forward by 1, so the index gives 1. Then the loop was skipped because the index is 1 and fails the condition of the if statement, which asks for an even index. So far it looks good. Then we do another iteration. This time we set a breakpoint here and click Continue. In the second iteration, our index is increased to 2, and so we enter the if block, and we get a sum of 2. But wait, 2 is incorrect. Do you notice any issues with the calculation? To be able to look at each Fibonacci number produced, we remove the semicolon, also remove the breakpoint, and stop the code. We run the script, and we get 2, 7, 20, 54, 143, and 376. That's totally incorrect. If we compare with our hand calculation here, we should get 138 until 144, right? Let's recap what happened. We calculated the next Fibonacci number, and then we updated the current number to be the next Fibonacci number, and the x minus n to be the current Fibonacci number. In the first iteration, we have calculated the third Fibonacci number, and the index is 1, and the sum is 0. And in the second iteration, xn equals to 2, xn minus 1 equals to 1. We calculated the fourth Fibonacci number, which equals to 3. The index was updated to 2, and we added the xn, which is 2, to our initial value of sum, which is 0. So it gave the incorrect number of 2. Did you find it? The index lags behind the correct index by 2. So the initial index is incorrect. It should be 2, because we should start from the third position when calculating Fibonacci numbers. So the index should be initialized to 2. And the initial sum is then the first two Fibonacci number, so is 0 plus 1, which is 1. So now we corrected the initial values. Let's run it again. Here we can see the outputs in each iteration. We get 3, 8, 21, 55, 144, which are correct. However, there shouldn't be 377. One more summation was calculated. Looking back at the statements, we can see that for the while loop condition, when the sum is equal to the target sum, it will conduct one more iteration. So we should remove the equal sign here. After the correction, we now rerun the script again to check if it now produces the expected output. We can see that the index number is 12 and the sum is 144, which is exactly equal to our target number. So the answer is correct now. To further validate the correctness of the script, we now change the target sum to 1000 and run it again. And this time it's still correct. You can try it with different target numbers by yourself. Okay, thanks for watching.